Creating Stored Procedures. In this nugget, I will introduce you to stored procedures in MySQL 5.x. Although the DBA2 exam objectives really covers stored procedures from a security context, I'm giving you this nugget as kind of an introduction to the topic for those of you who have never worked with procs before. What we'll do is begin at the beginning, and I'll introduce what stored procedures are, and then we'll get into, of course, the practical application, how to create, alter, and drop those procedures. This nugget I think you'll find is very helpful as we go through the course and start diving into the security aspects of MySQL, and by then we'll have a good grasp on how procs work, and it just won't come out of thin air or left field when we reach that part. Let's get to work. Stored routines. Let's begin by taking a look at a term you'll find in the MySQL documentation that might confuse you, especially if you're coming to MySQL from another platform, such as Microsoft SQL Server. Now, what does this term stored routine mean? Stored routine in MySQL nomenclature is sort of an umbrella term that embraces three very related database objects. We have the stored procedure, the function, and the trigger. Now, don't get me wrong. All three of these objects exist in any RDBMS worth its salt. Oracle, DB2, SQL Server, etc. However, again, maybe this term stored routines is a little bit centric to MySQL. I just want to make sure you understand it in case you see a reference to stored routines on your exam or elsewhere in the MySQL world in documentation. Now, specifically, a stored procedure is encapsulated, precompiled code that's stored in your database that specifically does not return a value to the user. Now, why would you use a stored procedure? Actually, let's hold that question until we define functions and triggers. Here we're just giving you the very technical differentiation among the three stored routines in MySQL. So a stored procedure is encapsulated business logic. We can think of it as compiled code that is stored as an object in a MySQL database. It can consist of one SQL statement or a whole bundle of those statements. In addition, we can throw in additional logic, conditional logic, branching logic, if then else. We can throw in a lot of really neat procedural-based programming that is normally considered fairly unattainable in a simple or real basic relational database management system. But again, the differentiator between a stored procedure and a function is that here we're not returning a value. The stored procedure is just kind of like if you've ever used a macro in a productivity application like Microsoft Word or Microsoft Excel. In other words, some pre-recorded series of steps that's used to automate some frequently repeated procedure. The stored procedure is called from the database. You actually use in MySQL the call keyword to invoke the stored procedure. The procedure runs, hopefully successfully, and whatever actions are encoded in the procedure take place. They're intercepted by the MySQL parser. The MySQL query optimizer takes care of any query operations, and you're done. By contrast, a function is, again, stored code in a MySQL database that's very similar in look and feel to a stored procedure. Again, it's precompiled code that's meant to encapsulate business logic. It's going to give you the ability to run parameters and set variables. You can put error handling in there and so on. We'll get to some of the specifics of at least stored procedures in this nugget. It's beyond our scope to get into functions, and in the next nugget, I'll introduce you to triggers. But really, the key differentiators between stored procedures and functions is number one, a function will always return a value to the user. And traditionally, it returns a single value, what's called a scalar value. An example of a function that we're going to use in this nugget is a pre-built function that comes standard with MySQL called count. You may be familiar with it. When you run select count against a column or against a table, what you're doing is invoking a function, some precompiled code that's going to count. In this case, if you run it or if you pass in the input parameter star or asterisk, you're passing in all rows as an input to this function. It's kind of like feeding coffee beans into a coffee mill or pasta sheets into a pasta maker if you're a culinarian like myself, and the function comes back with output that is scalar. In other words, the count function is going to come back with X number of rows, 1,000, 10,000, a million, or whatever, okay? Another neat differentiator between functions and stored procedures is that functions tend to be far more flexible than stored procedures. As I said, stored procedures are invoked with the call statement. You just simply run them. Now, you can extend stored procedures using parameters and variables, but it's just you invoke it with call and that's all she wrote. By contrast, you can invoke functions anywhere in an expression. You can use functions in select statements, in column declarations, in tables, and views. Functions tend to be far more flexible in their application. So that is really your take-home message if you were ever wondering, because otherwise they're very similar, what the key differentiators are between procs and functions. Finally, the third type of stored routine in MySQL is the trigger. And a trigger is another automation object. This one, instead of being associated with a database, is actually associated with a particular table. That's one thing I want you to remember. Trigger, table, T. Triggers are not associated with a database. And that makes sense because you implement triggers to put business logic, whether it's for security reasons, for automation, for data integrity reasons, for constraint purposes. You associate a trigger with either an entire table or just a table column, and you can have the trigger fire off either before or after a particular event takes place. In other words, you can capture all delete events on a table such that whenever a delete happens, those deleted rows get copied to an archive table. A lot of businesses want to make sure that no data is ever really deleted from a production database, or database table, I should say. Again, that makes good business sense because once something is deleted, it's gone forever. As I said, we'll talk more about triggers in a future nugget. To rein in our focus, let's look at just stored procedures for the rest of this nugget, and let's take a look again at the business reasons why we as database developers and database administrators and business analysts, quite frankly, would want to implement stored procedures in a MySQL database. These are some really good reasons here, friends. One is that stored procedures give us a packaged, reusable method for deploying business logic. You have things that you need to do on a regular basis in your database. You have, for instance, data input or data entry. And that data input or data entry may require some sort of cleaning or data validation. You may have batch updates that need doing periodically. You may have backup jobs. Think of all of what some DBAs refer to as scut work or just repetitive actions. Do you want to rely on interactive work at the MySQL prompt to get this stuff done? Do you even want to rely upon script files and using cron or task scheduler to automate these kinds of actions? Do you want to rely upon your application code to send SQL statements one at a time, one after the other, between your user's desktop application or from their web browser to your back-end server through your middle tier? I don't think so. There are so many reasons why stored procedures make so much sense. You've got a pre-compiled, packaged, and reusable module of code that makes it so much easier to maintain. After all, if you have that bundled code, that stored procedure that needs modification, all you have to do is modify the code in one place and everything follows through from there. Another advantage of stored procedures is this fact that we have error handling, conditional logic, and so many other advantages of procedural programming language. We have all of our SQL library commands available, and as well as a lot more. So we can do a lot more in terms of flexible coding and flexible business logic directly from within SQL. That tends to be, in my experience, one of the big push-pull relationships in an application development environment. There's always the question, how much code do you want to put in your application versus how much do you want to put on your database side? That's constantly a push-pull struggle. And with stored procedures, you're putting more of your business logic over here closer to the database and leaving more of the code towards the application for other reasons. Maybe you've got the application concerned with different sorts of logic that may not necessarily be tied directly to your data storage. However, your stored procedures do operate very closely and in a very near and dear fashion to your data store and your tables. So it seems to me very obvious for you to handle that procedure, that business logic, as close to the database as possible. Now, this is a really big issue here, especially over the last several years. Stored procedures are really the solution in terms of protecting your web applications against what's called SQL injection. Dollars to donuts, whenever you see a web application that's been defaced by a bad guy, it's a case of SQL injection. And what SQL injection is, very briefly, is a case where you have a web application that has something like a sign-in area, a username, and a password field that hasn't been properly sanitized. And what that means is, instead of a stored procedure that encapsulates that input, that username string and that password string, and forces just that data down into the database, if we're not using a proc for that, and we're just allowing the data input from the web form directly down into MySQL, you can see where that creates a huge security hole, because that allows the user hitting your web application to issue what are called ad hoc or free-form SQL queries against your database. And that's the nature of what's called SQL injection. And there are tons of exploits against different database platforms, MySQL included, that can allow root access, and once a user has root access or privileged access against your database tables, there's where you start to get into data defacement and possibly data loss or worse. You see what I'm saying? Therefore, we want to sanitize or make sure that the username and password fields are strictly controlled, so that data is passed into a stored procedure as input variables or input parameters, and they're cleanly being passed in a secure fashion to your database, and there's no way around that stored procedure. There's no way for this user to pass anything other than those two string values to the database. All right? So if for no other reason you need to use stored procedures for something like authentication to a web application. Finally, I've already mentioned easier code maintenance. That's certainly a good reason as well. Let's get to the meat and potatoes here. How do we create a stored procedure? Now, the example I'm giving here, and in the demo, I'm going to be working from the MySQL terminal monitor. Of course, in the real world, in most business environments, you're going to want to keep a record or an audit of these sorts of things. You'll want to keep a hard copy or an electronic version of your procedure code. So you'll have this stuff recorded in a .SQL script file. However, you can create your procedures interactively if you want to from the MySQL terminal monitor. To do that, though, you notice that you may have to monkey around with the delimiter keyword in order to get that done. Now, the delimiter keyword is interesting. Delimiter allows you to change the statement terminator from the default. Now, that's important when you're doing something like a procedure definition in MySQL, because a procedure definition, dollars to donuts, may contain more than one statement. This sample procedure, if we can just look into the meat and potatoes, contains two separate transaction statements, doesn't it? Remember that each statement, each transaction statement in MySQL needs to be terminated by a semicolon by default. So this procedure named staff store count is going to select a count of all rows from a staff list table and also a row count from a store table. That's what's going on in this particular stored procedure. The problem is, by default, MySQL is going to interpret these semicolons as soon as this line is entered, as soon as you press enter or return on your keyboard. Unless we do something to temporarily change the delimiter focus, this command will actually be intercepted by MySQL parser and will actually run. So it's important when you're constructing these procedures interactively that you need to temporarily change the delimiter focus. and you can change the delimiter to just about any other character. Okay, so we can use just about any character for your delimiter symbol. Traditionally, I use the double / just a convention, and that's a good one to use really because you find it won't create ambiguity. It would be a poor idea, for instance, to use a parentheses symbol as your delimiter because you're going to find that collides, or an underscore would be a bad idea. So I just, actually in the MySQL training materials, you'll find they use the double / as well. But just know that the delimiter that you choose is arbitrary. All right, and you, again, would just use this when you're in a condition, or a position, I should say, where the default delimiter may get accidentally or inadvertently parsed by MySQL parser, like in this case, if we're creating a procedure from within the MySQL client. At any rate, we've got the delimiter statement, we use create procedure, and then the name of the procedure. The procedure is followed by open and closed parentheses. There's some additional stuff we can do here if we're going to use input parameters. This is beyond the scope of this training. In the MySQL developer training, we go into this in great detail. Input parameters are simply data types that the user can add when the procedure is called. For instance, username and password in the previous whiteboard when we were talking about that. Output parameters can also be included in the procedure definition if the procedure is in fact going to behave kind of like a pseudo function and output parameters maybe to another procedure or send back to your application. But in our case, for this nugget and for your exam objectives, we're just going to do empty parentheses to specify no input parameters, no output parameters. Now, another hallmark of your stored procedure is we need a begin and an end block. The actual procedure needs to be enclosed between those two keywords. And what you include between the begin and the end is completely up to you and your development team. This is just a simple example, but you can just go to town here. See the MySQL reference manual for a full explanation of all the programmatic options you have here. You can include variables with the declare statement. When you use variables, you would declare a data type for those variables. Variables are simply buckets, data buckets of various sizes and shapes. Those sizes and shapes of the variable data buckets are determined by the data type that you associate with those variables. And variables simply allow your procedure to become more flexible because you can take data from, for instance, an input parameter and move it around and do different things with it. Simply makes your procedure more robust. If you have if, then, else, conditional logic, that's fine. If you have error trapping and error handling, that's all well and good. You do all that between the begin and the end. And then finally, you terminate the whole ball of wax after your final end with your defined delimiter. In this case, // enter, query OK. This is just some extra stuff. You can ignore that. Now, you're going to be surprised if you try to just execute some commands and go back to using the semicolon. Because once you use delimiter, in this case // for the rest of your session, you're still working with //. So make sure that you immediately set back your delimiter to the semicolon. You can do that by just typing delimiter space semicolon. And then finally, to run the stored procedure, you just type call space the name of the procedure, open and close parens, and then your statement terminator, and you're in business. Ongoing stored procedure maintenance. If you have any experience with data definition language or DDL SQL statements, well, you do now because create is one of them. DDL are simply the SQL statements we use to create, alter, and drop, or instantiate, alter, or delete, depending on how your vocabulary works, database objects. And it's the same thing with stored procedures. You can use altered stored procedure to make changes to the structure of your proc. You can drop stored procedure to drop the stored procedure. Now, you might be thinking, well, that's really great. Once I create my stored procedure, I know that the stored procedure is associated with the database. But if I run show database, I don't see the stored procedure. Where is that stored procedure in the database? How can I alter the stored procedure if I don't remember what the logic was? After all, your colleague may have written the stored procedure, and now you need to go in at 1 o'clock in the morning to make an alteration to it. How can you get its definition? Are you going to call up and wake up your colleague or ring him up on the phone when he or she is on vacation with their family in Hawaii? Well, you don't have to do that if, and that's a big if, you remember that MySQL includes a virtual database called information_schema. This is our data dictionary or our metadata database. And as it happens in information schema, there's a view called routines. Therefore, we can select against the routines view in information schema and simply filter if you want to. I mean, you can go about your select statement however you want to. This particular select statement simply grabs all of the stored procedures or stored routines from the Sequela database. There's a column in this routines view called routine schema. Now, if you've been following my nuggets all along from the CMA, the Certified MySQL Associate, through the Database 1 and now into Database Administration 2, you're well aware of this. Maybe you're aware of it anyway. What do I know? That in MySQL terminology, schema means database. So routine_schema means the routines database. So don't be thrown off by that word schema in this context. And the metadata here is going to come back with not just stored procedures, but also functions. Remember, stored routines in the MySQL context refers to stored procedures and functions. Now, notice that conspicuously absent are triggers. Triggers are associated with tables. Just a point to ponder. Finally, before we dip into our demo, let's take a look at the security permissions that are required. This is a little bit interesting in my opinion. Obviously, if you're logged into MySQL as a super user or root, you have all privileges, but at the very minimum, in order to create a stored procedure, you need to have the create routine permission. Isn't that interesting? There's a special permission to create a routine. You can have permission to create a table, but just that permission will not give you the permission to create a stored routine. That tells me that routines are quite a bit more powerful than many other objects in a MySQL database. To execute a stored procedure requires the execute permission. So then again, we can give an individual the permission to create a routine, but not to run it. And then finally, to drop a routine, there's alter routine. It's interesting and I think quite wise that the MySQL development team broke out these permissions for stored routines as granularly as they did. In the demonstration part of this nugget, we're going to create and test a stored procedure or two. Having done that, we're then going to pop open information_schema, and I'll show you how to view stored procedure metadata. Let's get rocking. Okay, let's get started with this demo in which we're going to work with stored procedures. We're working with LinNugget 1, our Linux machine. I've popped open a standard command shell, and as you see, I've already logged into MySQL client. We'll show databases, and you see we have the world sample database. No problem. Just for grins, I'm going to show tables. Whoops, we've got to use world. We'll show tables, and we have city, country, and country language. Pretty simple stuff. Now we're going to define two stored procedures in this demo. The first one we're going to define is directly from within the MySQL client. The second one we're going to do is via an .sql script file that will load in externally from the MySQL client. This is going to give you a little flavor of doing the work interactively and then more in a real-world context. Same basic procedure both ways. And the simple example I'm going to give comes from the MySQL training materials, actually. We're going to create a stored procedure that simply gives us the row counts from the tables in the world database. All right. Now, as you know, if we have one or more separate statements that will be terminated with the semicolon, we're going to have a problem if we're doing this interactively at the MySQL prompt, because whenever we do have, say, a select statement, and we hit go, that semicolon tells the MySQL parser to actually go ahead and move. Therefore, we need to begin our stored procedure with delimiter. So we'll just type delimiter, and I'm going to use // press enter, and we're given a new line character. Now the session variable has been changed overall, such that now anything I do in this session, whether it's a select, insert, update, delete, create, alter, drop, whatever, has to be terminated with a double /. So this is just a very temporary operation to be sure. I'm going to create a procedure called world_count. Remember that we're using no input or output parameters, so we'll just do empty parentheses. I'm just putting these statements on separate lines for clarity. You can run them all on a single line if you want to. And I'm using lowercase simply because I typed faster this way. With select statements, as we'll learn later in the course, case is very important even with your keywords. So I don't want to underestimate the importance of, in some cases, being more consistent with case, but it's not going to matter here. So I'm using lowercase even for my keywords. So we say create procedure, then the name of the procedure. We have to begin the procedure, and then I'll actually start my code. This is going to be very simple. I guess I will use uppercase for my select statement just to be safe. I'm going to retrieve all of the rows from the country table. Now, this is a little bit different. When we reference an object, we just learned about using the backtick to do quoted identification. But when we're in a stored procedure, we're actually using the single tick, such that, let me just finish this line and I'll explain. So what we're saying here is grab a full row count from the country table. Why is it that we're using single ticks here? Well, essentially, when you're in a stored procedure, this is what's called a string literal, and it's just basically the rules of the road. When you're referencing an object, we enclose this not with backticks, our standard quoted identifier, but with the string literal character, which is by default the single quote. So let me finish this out using the other tables in the world database. Once we've completed our code, throw in a new line and end that procedure, throw our final semicolon, which terminates this procedure. Enter, and then to actually submit the stored procedure to the MySQL parser, remember we changed our overall delimiter to the double /, and we have an error. You can see what the error is pretty cleanly here. We actually have an extraneous comma after the count for the city row and country language. I'm glad that this error is here because it underscores something important. If we did this code in a .sql script file, we can easily correct the code in the file and reload it. Here I'm going to have to retype this whole dadgum thing interactively in the MySQL client. Or better yet, I can use the up arrow key to reinvoke the last statement from my command buffer. I arrowed back and removed those two extraneous commas. We'll press enter and query OK, 0 rows affected. Great. So now at least ostensibly we have a stored procedure called world count associated with our world database that retrieves the row counts for all three tables in that database. Now that's nice because at least as far as our business logic is concerned, we can now run a single stored procedure that encapsulates 3 separate select statements. Another advantage of stored procedures that I failed to mention earlier in this nugget is that stored procedures save network bandwidth, because we can now call this stored procedure with one SQL command. We can simply invoke call world_count like that, and the person sitting at his or her client machine can issue this simple command from his or her workstation, and MySQL will run all 3 lines of code here on the server, and that would save what otherwise would be 3 separate statements. Now you might be thinking, well, Tim, yeah, big whoop, that's just 3 select statements. Well, if this were a batch job that had 1,000 statements in it, you can see immediately, would you rather have your user submit a single call statement over the wire or 1,000 separate statements over the wire? You see? I hope I've convinced you now, if I haven't already done so, of the amazing power of stored procedures. Now then, whoops, you know what I forgot to do? I forgot to set my delimiter back to the semicolon, didn't I? Well, I can always use the \C to escape out or clear my last command, and I can say delimiter space semicolon to bring us back to where we need to be with the traditional semicolon delimiter. I'll again use up arrow to bring back the call statement, and we're back in business. Excellent. Now, the second thing I wanted to do is let me \Q to exit out of MySQL, and we'll clear the screen. And I will also, in preparation, open up a new tab, is I want to create a script file that does basically the same thing to show you a more business-oriented way to do stored routines. Now, in this case, I'm logged on as trainer, and I'm obviously, if you've used Linux before, you see the tilde. My present working directory is home trainer, and that's exactly where I'm going to stay to create my .SQL file. I'm going to use Pico, my favorite editor, and I'm going to call this, how about worldproc.sql. And in this file, I will simply line by line define my stored procedure. And just to be safe, as a database developer in MySQL, I tend to include the delimiter statement just to make sure that we're not going to run into any problems with MySQL parser. Just like it never hurts to use backticks to qualify your object names, it never hurts to include the delimiter. So that's what I'm going to do. Set the delimiter, and then we'll create a procedure. Let's just call this test, and we've got our begin. What we'll do here is, why don't we call this test 2, because in the background, when I was actually testing, I created another procedure called test. And we'll do something else actually, kind of thinking on the fly here. One thing you might remember from when we created our first procedure is that we had to use the world database before we created that procedure. And actually, let me come back to my original prompt and log back in. It brings up an important point. If we just try to run that procedure, like now, right now we're not connected to a particular database. If we run show process list, root is not connected to a database. If we call world_count, it tells us no database is selected, because in the definition of that procedure, we didn't qualify what database the world_count procedure was attached to. We actually have to manually shift our focus to world and then run the procedure, you see? So it's not very smart programming on my part. Therefore, when you create your procedure, it's best to qualify those bad boys. So I'm going to create this procedure as Sakila.test2. So I tell MySQL what database that procedure is attached to. And then in my code, I'll run a select statement against my favorite table in Sakila, film, and we're going to run a count again, row count, no comma, from the film table. Just again, very simple procedure just to give you the idea here. And we're going to end with the double /, and this time we're going to actually include the closing delimiter in our code to make sure that the procedure resets the delimiter the way that it should. Also, what we want to do, just again to qualify, we're going to say select a row count from the film table, but we're going to say Sakila.film to make sure that we're fully qualifying our object. So let's save the file with Alt-O, and then we'll come back to our other prompt. I guess we could have stayed where we were, quite frankly. We'll quit out of MySQL, and now what we'll do is we're going to load that file in, like so, by running MySQL >worldproc.sql. There we go. Now let's actually log in as root. To test the stored procedure, we'll simply run call test2, and we're done. To finish this demonstration, we're going to connect to the information schema database. By the way, we can just run show databases to see that it's there. We'll actually use information schema to make it a little bit easier. We'll show tables, and you'll see that in the list of views in information schema, we have routines, and we can simply select star from routines where routine_schema equals, and then in single ticks, string literal, the name of the database. I would recommend you use the \G keyword, or it's an escape character, to give you a vertical display of the output, just to make it more legible. So what this select statement is doing is grabbing all of the columns from the routines view that gives us all of the routines in the world database. And of course here there's just the one, the world count procedure. And let's see what we got here. This is certainly going to be useful, like I said earlier, if you either don't remember what the definition of the routine was, or if you need to familiarize yourself with the routine if you're seeing it for the first time. This is by far, in my opinion, the most important field in that view, the routine definition field. Another field that's important that we'll look at a little bit later in this course is the definer field, because this would allow us, if we want to change the execution context of the stored procedure. In other words, you can have the procedure execute as an administrator and give an ordinary standard user the ability to execute the procedure. Creating Stored Procedures Review. In this nugget, I gave you what I believe is a good nutshell overview of stored procedures. I hope you understand what the stored procedures are. Actually, I hope you're clear on stored routines in general, which embrace stored procedures, functions, and triggers. Not only that, I hope you can give me, if I were to ask you, the advantages of stored procedures from a business perspective, as well as be able to sit down at a live server and create, alter, and drop stored procedures, as well as view stored procedure metadata. I hope that this has been informative for you, and I'd like to thank you for viewing.